kicked up quite a bit. Anyway, there's Boomer's Savonius. It was really moving here a minute ago. The clouds, I know you can't see them on the camera, the clouds are, got some going north, got some going south. The wind's coming from the south, nice good wind. And I see a couple of clouds going east. I thought I saw one going west. There's the big one. See it much. You see something moving there. That's the big one. It's turning slow. It always turns slow, but it always turns. This is the first one. None of these are producing power, so we're within the legal limits. This is the first one, the one we swore was going backwards that time. And here's the shot of the LEDs. Not bad lighting. It's pretty nice. It even shines enough light back there. I can see a little. There we go. This chain's a little bit tight on this. This is the Savonius. Savonius. Pretty windy out here right now. Anyway, they were all very good turbulent winds. You see right here, it's got a real small diameter sprocket. The sprocket over here is much larger. This is not centered perfectly, so it kind of makes a little undue noise if it's over tight in some spots. But how tight your chain is going to tell you how much friction loss you're going to do. Each one of them rollers is a friction. It's easier than, I mean, it's very strong and it's pretty efficient in its own feel there, but it still lost a lot of, these sprockets, this small sprocket here wastes a lot of efficiency. Because not only does it have the torque on two sides, two pieces of chain pulling this back this way real tight. It's also got, and that puts friction on the bearing here and the bearing over there. The diameter of this tells you how much force it actually takes to turn this thing. If it had one out here, it'd have a lot of leverage. You could turn 95 pounds of torque with a 2-foot breaker bar a whole lot better than you can with a 6-inch ratchet. So anyway, being this close to center, that's a lot of loss going to something like that. What I'm trying to get at here, if you want to save a lot, if you had a sprocket this big, out to about here, and a sprocket that came out to the full width of the barrel, you'd have a lot more efficiency. But this drags down. You get a little bit of a power reading here. I was looking at some nice voltages here a minute ago. I got this on AC. It's not through a rectifier. One of the bolts is missing. I need to put another one in there. It's got a nut inside that it'll thread to, so it'll still connect. At this slow speed, we're doing about 3 volts. Now we're up to about 6.7. You can watch the speed and listen to her. I can get this in the view of the camera. I hope that's enough to read. Oh, I got a reflection there, don't I? That's probably a lot better. Anyway, got around 7 volts. There we go. There's 11, 12, 13, 15 volts, almost 16. That's not too bad. I mean, that's a turbulent night before the storm. These things are generating a little electricity. I think it's great. It's not that loud. It's not loud like a but still, I tell you what, my crop's a lot less noisy than my neighbor's air conditioner. So, especially window units. Usually most window units are pretty loud, the older ones especially. I don't see where this much noise should make something outlawed. I think it's stupid. This ain't making much, neither is a little prop. When I finish making that other prop quiet, I'll show you how quiet it can be. you will not hear it. The human voice is usually right about 35 decibels when we're talking. I'm probably right about 40, huh? Anyway, just a note, I'm Scott Brown, Green Wind and Other Home Energies. Many good things to you and yours. Well, we got some nice winds down here, like I said, while we're playing around. This really isn't much louder than me. You can hear me talk. So anyway, even in these good turbulent winds, jump up and down. This has been charging a while. Yeah, it's saying about 15.57, so it charged this battery in no time. You kind of got to take it off. Now here's something else I want to show you. That wasn't good. Yeah, now we got some winds. I hope I got this aimed up there good. I was talking about matching a prop to an alternator. One thing you should always be able to do, stall that thing out by shorting it out. I'm not shorting across the battery, I took the other lead off the other battery. Anyway, you should be able to short it out just like that. And it should stop. The torque that it takes to stop basically went through the amps in the wire. The amps, that's a lot of power in a way. It's not power. Power is voltage times your amps. Voltage is the speed that the motor is going. How much is pressing on it to keep it going that speed is your amps. Resistance comes out in the mechanical. The mechanical is what the wind is pressing on. So the wind is kind of a sponge pressing on your electricity mixer. That's about it. You push so far, well, the battery drains so much current, it keeps the voltage down at its end. The voltage is not trying to go higher than the battery voltage much. Not very many amps flow. Put it all together and you multiply your amp times your volts, and you know how much power you have. Like I said, shorten it out, drop the power out now. Yeah. If you short yours out and it doesn't stop, it's not efficient. I'll tell you that right now. I'm Scott Brown with the Green Wind and Other Home Energies. Many good things for you and yours. Here, let me undo it, show you how fast it'll spin right back up. There we go. Let's short it out one more time. I think it's a little too windy for something that doesn't have to burn the next one. Short it out. If this was left allowed to go into the storm, we got some higher winds than this, we wouldn't have a wind turbine. That's what we call overspeed protection. This needs a furling mechanism. Right up there better. This needs a furling mechanism. It's not safe. Your treadmill motors need a much shorter prop and a furling mechanism. Treadmill motors a little bit more RPMs per volt than these old tape drive motors. And these things are bigger too. Anyway, that's what I call efficiency. This is shorted out right now. It's not going to do much. But if it had a furling mechanism, it would save the unit. I have to take it down tonight. I'm Scott Brown, Green Wind and Other Home Energies. Many good things for you and yours. Hola. Good deal. Took the items on my desk. The ring that fell off under the last video. The Kerpen saw. A thing called Helping Hands. Got that from Boomer. Well, actually, Boomer bought it. I said, Boomer, you got to get this. Anyway, there's the heat shrink tubing, screws, the light that we were using on the last video, my polarized sunglasses. I love them. Except when I'm doing camera work, you can't see. Ring lugs, big enough to fit on the terminals of the Power Jack 1200, and butt connectors. All of these, and we had these plugs were all set up. Anyway, we got up there to the solar panels. Now they got a totally different plug. Those butt connectors are going to come in handy. I hate cutting them, but we're going to use the heat shrink over them and seal them off real nice to the weather. Maybe we can put some Kiwi seal. That's where we're going to stick the boxes down and get all the joints and holes and everything that we're wiring up.